Hello, today I'm going to talk to you about Lesson 2-1, which covers three different topics: distance, midpoint, and slope. These are all going to be things that you can calculate between 2 points. The distance between 2 points, the midpoint between them, and the slope between 2 points. So as you can see at the very top, we already learned in Unit 1 that we can easily find the distance between 2 points, and we can also find the midpoint if they're just on a number line. That's quite simple. We learned the distance is just the absolute value of the difference between them. So you can say, if you're calculating the distance between points A and B, if A is at coordinate x1 and B is at coordinate x2, you would take the absolute value of x1 minus x2, or you can switch the order. It would be the absolute value of x2 minus x1. We also learned to take the midpoint of 2 points on a number line. You just add up the 2 points and divide by 2, which is another way of saying take the average of those two coordinates. Well, today we're going to learn how to do everything not on a number line, but on a coordinate plane, which is an xy coordinate plane. X, remember, goes in the left and right directions, and y goes in the up and down directions. So how would we do the same thing on a coordinate plane? The distance is a little bit more complicated. You can see the distance formula here. It has a square root symbol, and it has a lot more going on. Let me just show you how this was calculated. So we have these 2 points right here, and if you want, you can see, you can make a right triangle. And really what you have here is the x coordinates, the coordinate for x1, and this gives you the x coordinate for the other point, which is being given as x2. So we're just going to call that side A of the right triangle. And here you have your y coordinate for this point, and your y, which is y1, and then y2 represents the coordinate for the y coordinate for the other point. Let's just call this side of the right triangle side B. And since it is a right triangle, let's call the hypotenuse side C. And remember, the Pythagorean theorem is really something you could use whenever you have a right triangle and you're talking about their sides. And the Pythagorean theorem was just c squared is equal to a squared plus b squared. If you were to solve for c, c actually represents the distance between these 2 points. So the hypotenuse of this right triangle is the same as saying how far apart these are. And in order to solve for c, you would take the square root of both sides, and it's just going to be c is equal to the square root of a squared plus b squared. Well, what is a? A, remember, was just the difference of the x's, and the difference of the x's we can say x2 minus x1 as it appears here. And a, remember, in this Pythagorean theorem we had to square a. So x2 minus x1, we're going to square it, and to that we're going to add b squared. And b was just the difference of the y values, y2 minus y1. So you can see the distance formula, although it looks quite complicated with that square root and everything being squared, it's really just the Pythagorean theorem. So it's something you should be familiar with. And how about the midpoint on the on a coordinate plane? Before, for the midpoint, we took the average of the x values. So we added them up and divided by 2. We're actually going to do the same exact thing, but we need to treat the x's and y's separately. So to find the, if we have 2 points, x1, y1, and x2, y2, to find the average of the x's, we do exactly what we did before. Add up the two x values, x1 plus x2, divide by 2, and then put a comma, because that's our x point, that's our x coordinate, and then our y coordinate, we do exactly the same thing. y1 plus y2 divided by 2. So now we have our midpoint as a coordinate, an xy coordinate, the x value, comma, the y value. So one other thing you can find between 2 points is just the slope between them. So whenever you're given 2 points, you can calculate the slope quite easily. And the slope is just how steep the line would be between those 2 points. And yeah, it also, in other contexts, it can represent the rate of change of a function. You'll learn more about that in more advanced math. But any 2 points on a line can be used to determine the slope. It doesn't matter which 2 points you choose. As long as you choose 2 points, you can use them. But you really want to use the points that are easy to work with. Ideally, their coordinates would be whole numbers. So the slope of a line is the ratio of this. You should have learned before. It's just rise over run. So it's the ratio of rise to run. And what does that mean? Well, if your 2 points are x1, y1, and also x2, y2, these are your coordinates for your 2 points you're talking about. So slope, we use the lowercase letter m to represent slope. You'll see this a lot. You learned slope-intercept form. It was y equals mx plus b. So m just means slope. And as we just said, slope is the ratio of rise to run. So slope is rise over run. And how do you calculate how much you're rising between 2 points? It's just the change of y. So it's going to be y2 minus y1. And that's pretty much the exact same thing we saw in the distance formula up above. We had y2 minus y1. So that's the difference in how much you're rising. Now, how much were we running? We were running x2 minus x1, which is this bottom part of your triangle. So that's how much we're going to run again, x2 minus x1. So let's try an example. These are kind of long examples because there's 3 different things they want you to calculate. For the given points below, in this case it's points A and B, and there's coordinates provided, calculate the distance, the midpoint, and the slope of each coordinate pair. So let's just do them one at a time. I'm going to go ahead and do the distance first. I'll just go in that order. I'm going to go off the margin, into the margin a little. Distance is equal to, now I'm going to do the square root of my x2. It might help if you go ahead and label this. x1, y1, x2, y2. I'm going to say x2 minus x1, so that's 7 minus 2. I need to put that in parentheses and square it. Add to that the difference of y's, which is y2 minus y1. y2 is a 5. Oops, y2 and y1 was a 3. Let me just make that into a 3. I need to take that difference and again square it. So what does that give me? Distance is equal to the square root of 5 squared plus 5 minus 3 is 2 squared. And that becomes the square root of 29. So that's 25 plus 4, which is 29, which is approximately equal to 5.4. Okay? Now it might be helpful if you just go ahead and plot the points as the directions say. Let me go ahead and do that now. 2, 3, that's 2, 1, 2, 3. These are very small grids. And then 7, 5. 7, 1, 2, 3, 4, 5. I believe that's right. So this would be point A, and this would be point B. Okay, so I calculated the distance. It's approximately, okay, I'm going to go ahead and write that down here. The square root of 29, or about 5.4. If you plug that into your calculator, do the square root of 29, you can get the distance as a decimal. So what would be the midpoint? This capital M stands for midpoint, whereas the lowercase m stands for slope. Midpoint is where you have to treat the x's and y's separately. And we're going to average the x's, x1 plus x2. So that's going to be 2 plus 7. And to take the average, you have to divide by 2. And do the same thing for the y's. y1 plus y2. And again, divide by 2. So the midpoint, that's going to be 9 divided by 2. So that's really all you got to write. I think the key is wrong for this one. So that should be 9 over 2 in parentheses, and then the other one would be 8 divided by 2, which is 4. So you could call it 9 halves, or you could call it also 4.5, comma 4. Whichever way you want to write it. It's really up to you. I'm just going to pick the second way. So that's how that would be. It would be 4.5, comma 5. That's exactly where the midpoint, 4.5, comma 4. That's exactly where the midpoint would lie. Okay, how about the slope? Slope, recall, is just rise over run. For slope, it's just the difference of y's and the difference of x's. So you can just do it exactly the same way we did up above. We already took the difference of our y's. This is y2 minus y1 over x2 minus x1. So it's going to be a lot like the distance formula, except we don't square it and we don't add them together this time. But you do have the same difference. So it's 5 minus 3, which is 2. 7 minus 2 is 5. So that is your slope. 2 divided by 5, or 2/5. We usually leave our slope as a fraction, or as a whole number. We don't usually convert to decimals because this represents rise over run, and it's nice to have them in a fraction form. Okay, going on to the next example, we have points C and D. C, let me plot it this time, was negative 3, comma 5. And D was 1, negative 1. So that's 1, negative 1. So C and D. Okay, so let's do the same thing. Distance, midpoint, and slope. The distance between them, okay, I'm going to again label x1, y1, x2, y2. You don't have to do that, but I find it very helpful. So the distance was going to be x2 minus x1. So that's 1 minus a negative 3 squared. And you're probably going to want to go and change that minus a negative to plus a positive. Just change those both to be plus signs. And then to that, that's the difference of x's. The difference of y's is going to be negative 1 minus 5. And square that. So this distance becomes the square root of 1 plus 3 is 4. 4 squared plus, and this was negative 1 minus 5. It's negative 6 squared. When you calculate this, you get distance is equal to 16 plus 36, which is the square root of 52, which is approximately equal to 7.2. So that is your answer. The square root of 52, which is the exact answer, or the approximate answer is 7.2. You should be prepared to write either one of those, depending on how the question asks you for the answer. Okay, midpoint. Midpoint would be the average of your x's and your average of your y's. So my x's are going to be negative 3 plus 1 divided by 2. The y's are going to be 5 plus a negative 1 over 2. You can say 5 plus a negative 1, or you can say 5 minus 1. Either way you want to write it. But your midpoint is going to be, what is that? Negative 2 over 2, which is negative 1. And you can use your calculator for these if you have to. 5 minus 1 is 4, divided by 2 is 2. So the midpoint would be negative 1, comma 2. Lowercase m, remember, represents your slope, and that's the change of your rise over run. The rise was your difference of y's, so it's going to be -1 minus 5. And we already did that up here. -1 minus 5. And then we also did, what was it? 1 minus a -3. And we already found that to be -6, as we saw here, and 4. The only thing is, -6 over 4 is our answer, but we can reduce that. You want to reduce each by a factor of 2, so divide each by 2, and you get -3/2. So your answer is -3/2 for your slope. The rise over run is -3 over 2. Okay, so that's how you can calculate distance, midpoint, and slope between any 2 points. On the next side of the page, we really just have some more practice to start off with. These require a lot of practice because there's so many numbers involved, so it really is good to do more than one or more than a couple of problems. So now we have 2 more different examples. These are kind of unique because of the way they end up. So E is at -4, 4. 1, 2, 3, 4. -4, 4. And then the other one, F, I'm just going to label that as E. F was at 6, 4. 6, 4. Okay, so what is going to be the distance? The distance for this is going to be a little bit different. Again, I'm going to label x1, y1, x2, y2. So I'm going to do x2, the difference of the x's, which is x2 minus x1, 6 minus a -4. I'm going to go ahead and just change those to plus signs right now. Square that, and then add to it the difference of y's, which is y2. Yeah, just making sure I did that right. Y2 is a 4, y1 is also a 4, which is why this problem is a little different. Okay, well that simplifies quite nicely. 6 plus 4 is just 10. And then the other one becomes 0 squared. You might be wondering, why didn't I use parentheses this time? You really can use parentheses. The only time you really need parentheses is when this is negative. But it's probably a good idea to use parentheses every time anyway, if you want to get in that habit. But if you had a negative number, when you square it, it must become a positive number, okay? That's why parentheses are helpful, especially for the negative numbers. Anyway, so what does this become? This becomes the square root of 100, which is equal to exactly 10. So your distance is not as hard to calculate this time because there was no difference between the y values. This is really just like a number line problem going left and right. So that was your distance of 10. Your midpoint is the average of your x's. Your x's were -4 and 6, so you add them together, get their average by dividing by 2, and then the y values you're going to also add it together, divide by 2. So what's the sum of -4 and 6? That's going to be 2 over 2, and the sum of 4 and 4 is 8. Divide that by 2, you get 4 again. So if you average 4 and 4, of course the average is going to be 4 again. So the midpoint turns out to be 1, 4. Because 2 divided by 2 is 1. Okay, finally, what is your slope? Slope is rise over run. The change of y's we already did before. It was 4 minus 4 over, that should be a 4. 4 minus 4 over, okay, and then we had x2 minus x1, 6 minus a -4, or 6 plus 4. That gives you 0 over 10. Now what is 0 divided by some number? You would not say that it is undefined. Undefined is if you had a 0 in the denominator. If you have a 0 in the numerator and you're dividing by some other number, that is just equal to 0. So our slope is equal to 0. It's a 0 slope line between these 2 points. So anytime it's going horizontally, that has a slope of 0. Okay, contrast that with this next problem. Let's plot the points x and y. X is -1, 7, and y is -1, +1. Sorry, -1, -1. Let me darken those. So x, comma, y are my 2 points. Okay, so what is the distance between them? Again, just use your labels: x1, y1, x2, y2. Distance is equal to the difference of x's, x2 minus x1, -1 minus a -1. Square that and add to it the difference of y's. So -1 is y2 minus 7 is y1. Square that. So your distance comes out to be -1 minus a -1 is the same thing as -1 plus 1, which is 0 squared, plus -1 minus a 7 is -8, because they're both negative. Square that. Your distance turns out to be 0 plus 64, which is 64, which is exactly equal to 8. So again, we had a whole number. And this is really like going on a number line again, because you're just going straight up and down. We didn't actually go left or right at all. What would be the midpoint? The midpoint would be the sum of your x's and divided by 2, which is just the average. So that's -1 plus another -1 over 2, and the average of your y's, which is 7 plus a -1, or you can just say 7 minus 1, whatever you want, over 2. So what does that come out to be? The midpoint is -1 plus another -1 is -2. -2 divided by 2 is -1. 7 plus a -1 is 6. 6 divided by 2 is 3. So the midpoint between them would be right at -1, 3, which looks about right. -1, 3 is right in the middle. Finally, what is the slope? This one you have to be a little careful with the slope. The difference of y's was -1 minus 7, so that's -1 minus 7. Difference of x's we did right here. It was -1 minus another -1, which is the same as -1 plus a 1. And this is where the problem happens. -1 minus 7 is -8, but -1 plus a plus 1 is 0. And remember, whenever you're dividing by 0, that means this is undefined. So what is your slope? Your slope is also undefined. So you have two extreme examples here. Normally our slope would be some kind of fraction or some kind of number. This time it was 0 divided by something, which is 0. Here it was something divided by 0, which is undefined. So whenever you have two vertical points and you have a vertical segment or a vertical line between them, that line will have an undefined slope. Whereas when it's horizontal, that has a 0 slope. Okay, so there's two more problems on this lesson. And what you're going to want to do is determine from the graph what the slope is. Just the slope this time. So first of all, it helps if you can count it. Okay, this one has an x value of 0 because I didn't run to the left or the right. I didn't go left or right at all. 0, but I did go up 2. So this is 0, 2. And then I went over to the right by 5, but I didn't go up or down at all. So it's 5, 0. So what is the difference of x's? You can do this in a couple of different ways, but you could just say x1, y1, x2, y2. What is the difference? What is the slope? Slope would be the difference of y's, which you could say 0 minus 2, and the difference of the x's, which is 5 minus 0. So that gives you negative 2 over 5. Negative 2 over 5 is your slope, and you can write it like this, or you can usually say the negatives out in front. Negative 2/5 is your slope. So that's how you calculate that slope. It's very easy, especially when you have some zeros involved. It helps the math quite a bit. So the first thing you really want to do, we'll try one more example. Notice this is a falling slope. It's a negative slope, which means as you go from left to right, the line is decreasing. That's why the decreasing line has a negative slope right here. This one, on the other hand, is rising from left to right, so this will be a positive slope. But first, let's identify our 2 points. This is at negative 4, 0. This is at 3, sorry, I said that wrong. 0, 3. So those are your 2 points. Negative 4, 0. I'm just going to call that x1, y1, x2, y2. What is my slope? Slope is equal to y2 minus y1, so that's 3 minus 0, over x2 minus x1, which is 0 minus a negative 4. And of course you're going to want to change that to be plus a positive 4. So that gives you 3 over 4, which is your answer. Your slope is 3/4. Notice this is a positive slope. Positive 3/4 means as you go from left to right, the line rises. And that will do it for today's lesson. If you didn't understand any of it, please go back and review it in the video.